Okay, we're on lesson 70. Now we're solving direct variation problems. We just talked about direct variation. Now we're going to solve some real-life problems with them. Okay, so here's your objective. Get it written down. And we'll jump into the first example here. It says, the amount Ellen charges for banquet food varies directly as the number of people that attend. Okay, so that means for every person that attend, Ellen is going to charge a certain amount. Maybe she charges $5 per person or $10 per person, whatever it is. Okay. Well, this says that she charges $780 for 60 people, and we want to know how much does she charge for 100 people. Okay, now before, we would have solved this with a proportion. Okay, we would have put 780 over 60 equals what over 100, cross products, and solved it. Okay, now the only thing is that instead we can write a direct variation equation for this. Okay, so that way, if I wanted to solve this problem for 100 people, and then turn around and solve for how much it would cost 175 people, I wouldn't need to set up a whole new proportion. Okay, I can just use this equation here. So the very first thing that we're going to need to do is set up the equation, okay? And our steps are going to be over here after that. So we need to think about how these things go together. Well, I know that the money that Ellen makes, here the money that she charges total, is going to equal, and it's going to equal the number of, or the money that she charges per person. So that should be the same for each person, times the number of people that attend. Okay? So now I can plug in some numbers I know to this equation to determine the constant proportionality. Because remember, we need to write an equation in the form y equals k times x. Okay, so we need to figure out what this k is. We're trying to figure out how much money she makes per person. We know that she charges $780 for 60 people. So we don't know how much she charges per person, but we know that there's 60 people that go. So now we need to solve for k. So what I'm going to do is divide by 60 on both sides of this equation to solve for k. And if I take 780 and divide it by 60, okay, we should know by now that's the same thing. I can knock off the 0. That's the same thing as 78 divided by 6. Okay, from knocking those out of there. Well, 6 goes into 7 one time. I get 18, and 6 goes into 18 three times. Okay, so that's $13 per person that she's going to charge. And now I'm going to use that to write an equation in this form, where I'm going to plug in my number for k. Alright, so that was all step 1 right there, figuring out what k is. Now I'm just going to say that my y is going to equal $13 times x. Okay, that's my equation. And again, x is the same right here as the number of people. And y is the money that Ellen charges. Well, now I want to figure out how much money she's going to charge for 100 people. So I'm going to plug in 100 for my number of people variable, which is x. So I'm going to say y, whoops, move this up here, y equals $13 per person times 100 people. So that means that y is 1,300. Okay, so she charges $1,300 for 100 people. Again, I could have solved for that using a proportion. However, now the nice thing is, once I've got this equation figured out, again, I could figure out how much it would cost 125 people, or 150 people, or 1,500 people. Okay, just by plugging in those for that number and taking them times $13 per person. Okay, let's move on to another example. In example 2 says, driving at a constant speed, the distance Maggie travels varies directly with the amount of time she drives. If Maggie drives 75 miles in 1.5 hours, how long does it take her to drive 100 miles? So again, we know that Maggie's distance is going to equal her speed times how long she drives. Okay, that's the distance formula, okay? Instead of speed, we can say rate. Distance equals rate times time. And speed is a rate, okay? 75 miles per hour would be a rate, okay? So we know that she's driving at a constant speed, so it says that this number isn't going to change, and these two will. So that's how we know it's direct variation. Okay? And it says she travels 75 miles in 1.5 hours. So her distance is 75 miles. We don't know her speed. And it takes her 1.5 hours. Okay? Well, to solve for her speed, because we need to remember, first solve for the k variable, that's the constant variable, we're going to divide by 1.5. To figure out what her speed is. So if I take 75 divided by 1.5, and I can't do that, I've got to move the decimal over. So I've got to move it over here. So that is now like 75. Okay, and see how many times that goes into 750. Well, 15 goes into 75 5 times, and that's 25, carry the 2, and 75. And we get 0, so that's 50 miles per hour. Okay, so that is my constant speed. That's my k value. So now I'm going to write the distance equation in y equals k times x format. So my distance, okay, remember this is y equals k times x format, equals 50 miles per hour times the time. Okay, so if she drives 1 hour, then she's going 50 miles. If she drives 2 hours, so on and so forth. Okay, and I want to know how long does it take her to drive 100 miles. Okay, so I'm going to plug 100 in for my distance and solve for my time. And 100 divided by 50 is 2. So my time equals 2, or 2 hours. And again, the nice thing about knowing her constant speed is that then I can figure out how long it's going to take her to drive 125 miles, or 130 miles, and so on and so forth. Alright, we got one last example. Alright, in example 3, it says there were 23 people in a line in front of Delia waiting to be helped. 3 minutes later, there were 18 people waiting. Predict how much longer Delia will wait to be helped. Okay? Well, we know, okay, that this has to relate directly if we can figure out about how much time it takes them to help each person. Okay? So we know that the time it's going to take is going to equal the minutes per person, or the time per person, times the number of people they need to help. Okay? Well, I can figure out the time per person by figuring out how many people that they have helped and how long it's taken. Okay? Well, there were 23 people to start, and, okay, first of all, sorry, it took 3 minutes, okay? We need to figure out how many people they helped in those 3 minutes. Well, there were 23 people to start, now there's only 18. So it took them 3 minutes to help 5 people. Okay, so that's about 0.6 minutes per person. Okay? Well, we know it's going to take about 0.6 of a minute to help each person. So I can plug that in for the time per person. Okay, so our time is going to equal 0.6 times the number of people. Well, we know there's 18 people left, so we need to figure out how much longer it's going to take her to be helped. So our time is going to equal 0.6 times the 18 people that are left. Well, if I take 18 times 0.6, and that's 48, carry the 4, 6 times 1 is 6, plus 4 is 10. So that's 10.8 minutes, okay? So it'll take about 11 minutes. We could say 10.8 minutes. We'll go ahead and round it off to it'll take about 11 minutes before she is helped. So that's her waiting time, approximately. And that's your lesson on direct variation word problems. Good luck on the homework.